When you hear the word fermentation, your mind probably jumps to things like beer or bread, maybe even kombucha. These ancient crafts, right? Well, what if I told you that same ancient process is being supercharged, turning into one of the most powerful engines for the future of medicine and technology? Okay, let's get into it.
For the longest time, the story of making complex things, like medicines, started out in a field. You'd have to grow a whole plant and then go through this incredibly costly and difficult process just to get a tiny amount of the one valuable molecule you actually needed. Well, that's all changing. The future isn't about harvesting from the soil anymore. It's about programming in the lab. We're literally moving from the farm to the bioreactor.
So, how exactly did this happen? This is a huge leap, right? Well, let me tell you, this is definitely not your grandfather's fermentation. We are talking about a total high-tech evolution of an ancient craft. Yeah, what used to be kind of an art form, a little bit of this, a little bit of that, a lot of trial and error, is now this incredibly precise, data-driven science. This is where you see microbiology, metabolic engineering, and robotics all coming together. We're not just hoping the microbes do their thing anymore, we are giving them an exact set of instructions and the perfect environment to carry them out.
And the real stars of this whole revolution are, well, they're microscopic. We're talking about tiny, single-celled organisms that we've essentially turned into fully programmable, living factories.
And really, it all boils down to one word: control. So, modern microbiofermentation. What is it? We take a microorganism, like yeast, and we put it in a bioreactor. Think of a super advanced sterile steel tank. And inside that tank, we control everything: the temperature, the pH, exactly what it eats. We program it to munch on simple sugars and in return spit out these incredibly complex and valuable products. It's manufacturing on a microscopic scale.
And the menu of what these little factories can cook up? It's just staggering. Seriously, by tweaking their genetic recipes, we can get them to make everything from bioplastics that could help us fight pollution, to the industrial enzymes that make our laundry detergent so powerful, and even the alternative proteins that might just feed the world.
Now, to really see just how powerful this all is, let's zoom in on a fantastic real-world example, using yeast to brew cannabinoids. Yep, those are the active compounds you find in the cannabis plant.
So, why cannabinoids? Well, because trying to get them from plants is a massive headache. It takes up a ton of land, water, and energy. On top of that, the crop yields can be all over the place. And here's the kicker. Some of the most medically promising cannabinoids are found in such teeny tiny amounts in the plant, it's basically impossible to extract them in a way that makes any economic sense.
So, the scientists needed a new factory. They looked at the usual suspects, right? You've got E. coli, and of course, good old brewer's yeast, S. cerevisiae, which is great because it's already generally recognized as safe by the FDA. But the real superstar, the one that blew the others out of the water, was a different kind of yeast called Yersinia lipolytica. And you can see why right here. It's just naturally fantastic at making the key starting ingredients, and it's way better at handling the really complex enzymes needed for the final assembly. It was the perfect little brewmaster for the job.
Okay, so we found our champion microbe, but how in the world do you teach a yeast cell to make something as complex as a cannabinoid? Let's dive into the how-to of this whole biomanufacturing process.
It really breaks down into a 4-step recipe that gets written directly into the yeast's DNA. First, you rewire the yeast to crank out a ton of a key ingredient called olivitolic acid. Second, you do the same thing for another crucial ingredient, GPP. Step 3, you introduce a special enzyme. Think of it like a molecular chef whose only job is to combine those first 2 ingredients. And then, for the final step, you optimize that chef to make it work faster and more efficiently than ever before.
And this final step is where the real magic happened, the big breakthrough. The researchers figured out that if they put 2 different versions of that chef enzyme into the cell, the enzymes would naturally clump together, forming these tiny condensed bubbles. This acted like a super efficient assembly line, pulling all the ingredients in the machinery into one tiny spot, which just massively sped up the whole process. It's absolutely brilliant.
And the results? They were really impressive. By giving their engineered yeast just a little bit of a head start with one of the precursors, they were able to produce 15.7 milligrams per liter of CBGA. Now, CBGA is often called the mother cannabinoid because it's the starting point for so many others. That number, 15.7, is what's called the titter, or the final yield, and it was the highest ever reported in this kind of yeast. It was a slam dunk proof that the system works. Now, a breakthrough like this is way more than just a cool science experiment.
This has huge real-world value. And that means we're moving from the academic lab bench out into the world of business, a world where you have to protect your innovations. And when an idea is this valuable, you patent it. The core methods here are being locked down as intellectual property. This quote from a US patent talks about producing polyketides. That's the broad chemical family our main ingredient belongs to. This shows you that these ideas are seen as incredibly valuable assets worth protecting legally. And these patents aren't just collecting dust in a file cabinet somewhere. They're assigned to real companies that are turning this science into actual products. In this instance, a company called Hyacinth Biologicals is the one commercializing this tech. This is all the proof you need that biomanufacturing isn't some far-off dream. It's here, and it's attracting serious investment right now. So the biggest takeaway from all of this is that the technology platform itself is so much bigger than just making one type of molecule. What we've just walked through with cannabinoids, that's really just the proof of concept for a whole new way of making things, a new era of manufacturing. The exact same principles, programming simple microbes to build complex products, can be used almost anywhere. We're talking about making sustainable bioplastics to replace oil-based plastics, developing alternative proteins to help feed a growing planet, creating rare flavors and fragrances for our food, even designing advanced biofuels. The possibilities are enormous.
It really just opens up a whole new world. I mean, think about it. We went from using yeast for thousands of years to make bread and beer, to now using it as a microscopic, programmable factory to brew medicine on demand. It just leaves you with this one incredible question. If this is what's possible today, what on earth are we going to brew up tomorrow?